Welcome everybody. It's now time to look at a video creatively called Expanding 101. Yeah, it's not real good, is it? Anyway, it's to do with algebra. We're going to look at why we expand and try and relate it to something meaningful, and then look at a few examples and the processes involved. All right, so with numbers, the operations to deal with numbers, we have adding. What's the opposite of adding? We have subtracting or minus. With multiplying, we have a division, which is the opposite, and you might have heard of indices and its opposite of logarithms. Well, to do with algebra, we have opposites as well. We have expanding and factorizing, but this one, of course, we're just going to look at expanding. There's a whole nother video on factorizing and the do's and don'ts and how-tos of factorizing, but for now, expanding. First up, why do we do it? Well, good question. Often it's simpler. We try to make things as simple as possible, but occasionally we can miss vital information. Now, especially with algebra and graphs, the best way to have a look at this is having a look at a few examples. So we'll take linear graphs. Most of you have done linear graphs. They're straight line graphs. You have dots which go in a dead straight line, whatever direction they're going, but it's a dead straight line. Okay, the basic rule for a linear graph is y equals m is the gradient times x plus the c, which is the y-intercept. That's great. So let's have a look at an example of that. Y equals 2x plus 3, just over here. And here's the graph. It goes through the point here, which looks like about 1.5, and goes up through negative 1.5 and 3. Okay. Oh, look, there's a 3 there. That's the y-intercept. That goes through the point 3. If we have a quadratic graph, we have a basic equation, y equals ax squared plus bx plus c. Don't need to be Einstein to figure out what the c is. The y-intercept again. Do you need proof? Here we go. Here's the graph. Y equals x squared minus 2x plus 3. And there it goes. Look, straight through the 3. Cubic graph. Let's look at another one. So a basic cubic graph is an x cubed graph. That's a d. Why is it a d? Well, you can see why it's a d. They've run out of x cubed, x squared, x. I needed the c for the x, so now they just use the d instead. But it's still the number tacked on the end, isn't it? So over here, let's look at this graph, x plus 3, and there it goes, straight through the point y equals 3 on the graph. Now, all these are in expanded form, these equations. If we wanted to know what the x-intercept was for that one, or not so much that one, that doesn't have any x-intercepts, but if we had a graph that came down through here and went back up through 3 there, then we would need to factorize those equations. So you can see you get important information out of both forms. You get the x-intercept if it's factorized, or you get the y-intercept or the c value / d if it is expanded. And that's just one example. There are others too where you're working out practical problems, areas, volumes of various shapes. And if you're trying to set up a rule, then you would set the rule up for the perimeter or the area, whatever it is, using algebra, and you could either expand it or factorize it. Anyway, that's for another time. Let's have a look at how we do it. So really, it's pretty basic. It is just the distributive law. That's it, distributive law. What does distributive mean? It means something gets distributed across everything. Now, here's the law in algebra. Well, this isn't the law. This is the background. This is in factorized form. So what we're going to do is distribute this A across the whole brackets. Now, if you remember, brackets keep things together. So at the moment, we've got factorized the B plus the C. That was a common factor. Or sorry, this was a common factor to both of those things. Now we have to expand that out. So what we're going to do is we're going to apply this A in red. We're going to multiply that by the B. And what do we get when we do that? We get AB, A times B. Now we have a plus here. Now this is a positive. This is one bit we'll go through many times in this video. positive and positive make a positive, a plus. Next thing we do, we have to distribute that A across the C as well. So A times the C, which gives us AC. This is in expanded form. All right? Making a lot of sense? Not really. That's fine. Here's how to do it with some practical examples. First one, 3 brackets x plus 2. So we're going to multiply by that 3 by everything in the bracket. All right? So first up, 3 times the x equals, of course, 3x. Now we have a positive here and a positive here. So we're going to put a positive there, a plus. Then we do 3 times the 2. Straightforward. 3 times 2, of course. This one you can simplify. What is 3 times 2? It's 6. So we can just write 6. That's it. That's as easy as it is. Another one. 5 brackets x minus 4. So first up, 5 times the x, of course, is 5x. Now, remember I mentioned about positives and positives and positives and negatives? We've got a positive there, but we've got a negative there, haven't we? What's a positive and a negative make? Positive and negative makes a negative. So, put a negative there. Now, this is just a tip I'm going with. Here we had a positive and a positive. Here we had a positive and a positive. Here we've got a positive and a negative. So, just the tip is, from me, calculate the signs first. Then you just have to worry about the numbers. Okay? It's much easier in your head to do 5 times 4 than 5 times negative 4. Well, it's a little bit easier anyway. If you get the negatives out the way first, and positive negatives out the way, or negative negatives, either way, out the way first, then it's just 5 times 4, which of course is there. And we all know that's 20. Okay, let's have a look at one more of these. Now we've got, you can see we've got a negative and negative. So first up we have to do negative 2 times 4. So we better write that one out. We'll just write that one there because it's got an x in there. Negative 2 times 4x. Sorry, I didn't say the x before. So it's the outside times the first one on the inside. Now we have a negative and a negative. So negative and negative makes, you guessed it, positive. Now we have 2 times 6, which is 2 times 6 is 12. I'll do that in the next line, actually, because we've got to do this one here. Negative 2 times 4. So negative times a positive is negative. 2 times 4 is 8. So that's negative 8x. 2 times 6, of course, is 12. So we're just simplifying. So it's expanding out and then simplifying. So please, take out of that, watch the signs. Do the sign, calculate the signs, the positives and negatives first. Then it's just the numbers. All right. It does get slightly more involved than that. We are going to have a look at binomial products. What does that mean? Well, that looks something like that. That's a binomial product. But the good news is it works in exactly the same way. So all we're going to do is distribute all the terms in the first bracket across all the terms in the second. So we're going to do the A times the C. And, remember to calculate your signs first. Now that's quick check. Positive, 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 positive. They're all positives. That's good. So in this one, we don't have to worry about it. So I've done the A times the C. What do we get? AC. Then we're still on the A. We haven't multiplied. We have to multiply by everything in the second bracket. So we're going to multiply it by the D as well. So it's going to be plus AD. So we've done the A times both things. Now we do the B times both things. So first up, B times the C, which is, of course, BC, and B times the D, which gives us BD. All right. So it's just 4 steps on this one instead of 2 steps. Let's have a look. Oh, actually not. Let's have a look just yet. There's an acronym you might hear. Some of your teachers might tell you this. It's called FOIL. sometimes helps you remember how to do this. It stands for first, outside, inside, and last. Okay, so there's your first, and there's your first. So multiply your firsts. Then you do the outsides, the A and D, multiply them. Then you do your insides, B and C, and then you do your lasts, B and D. It can help, but FOIL only works when you have two brackets. All you're really doing is using the distributive law, okay? If you have more than two brackets, FOIL doesn't work. You've got a middle term as well. You will end up with a middle term, and FOML doesn't really have the right ring to it, F-O-M-I-L. So I personally don't like using FOIL, using the word FOIL. If it helps you remember for the two brackets, just go for it. That's fine. All right, let's get rid of that, and we'll do an example now. First up, this is what we mean. X plus 3 brackets X plus 2. So first up, we're going to do the X times the X. So X times X is, of course, X squared. It's a positive. Do we have to deal with any negatives in this one? No, we don't. So they're just all going to be pluses. That's good. It makes it easier. So X we've done with the first one. Now we do X with the second one, which is 2. What's X times 2 is plus and 2X. Now that X is done with. Cross it off if you like. Now we're going to do the 3. 3 times the first one. 3 times X is 3X. And then we're going to do 3 times the last one, which is 3 times 2, which is, of course, 6. Now, with this, depending on what the pronumerals are in here, if they're the same pronumerals, you're going to end up with 99 times out of 100, something you can do with these two in here. We know what 2x and 3x are, don't we? Or is. We've just got the x squared there, so that doesn't combine with anything. Can't simplify that. So we've got the x squared, but 2x and 3x is, of course, 5x. And we've got the plus 6 sitting on the end there, so we just have to leave the plus 6. And that's it. So it's really only a couple of extra steps. It's multiply each of the first by each of the second. All right, another example, but this one's got some minuses in it. See, there. So let's have a look. So we've got a -3 there, or a -3. All right, let's go. First ones, 2x times x is 2x squared. Now we've got the 2x times the 5. So 2x times 5, 2 times 5 is 10. That's a positive and that's a positive, so that's positive. 2 times 5 is 10, so we've got 10x. Now we've got the -3 times a positive x. So negative and positive makes negative. 3 times x is just 3x. And the last one we've got -3 times positive 5. So negative positive is negative again. 3 times 5 is 15. We can combine these two. So that's positive 10x, take away 3x. Before we do that, we've got to just dump this 2x squared out the front. That's still there. 10x minus 3x is positive 7x. And we've got minus 15 on the back. That's as hard as it gets. Don't believe me? Well, it is as hard as it gets, really, even though, what if we've got a third bracket? We're still going to use the distributive law. We're just going to do 2 brackets at a time, though. You'll see what I mean. Here we go. X plus 3, X plus 2, X minus 9. Now, it doesn't actually matter which 2 brackets you do at a time. You can do the first 2 or the second 2. Personally, I like to do the back 2 first and then worry about that, because then I've only got 2 multiplications I've got to do, 2 things I've got to distribute, rather than if I did those 2 first, I'd have 3 things I'd have to distribute. Doesn't matter. You'll get the same answer if you do it correctly. I'll just show you this way if you like. All right, so we'll worry about these 2 first. So we're going to start with this x and this x. X times x is, of course, x squared. Now notice how I've written it straight underneath, so I know where I'm up to. Okay, Next one, we've got x times, now that's a -9, isn't it? Positive and negative makes minus. X times 9 is 9x. Now we'll do the inside ones. 2 times x is plus 2x. And positive 2 times -9, positive negative is negative. And 2 times 9 is 18. All right. Can we simplify that at all? Look in the middle. Yes, we can. -9 plus 2. We can do that. And that becomes, bring down the x squared, minus 7x minus 18. Good so far? Now, here's where we distribute again, but we've got to bring down this bit to distribute with everything there. Now, how do we keep everything together again? Oh, that's right. We use brackets, don't we? Let's put it in brackets and we'll bring down the x plus 3. Now we can just distribute, but this time, you see, we're going to distribute this across the 3 things, then we'll do this across the 3 things. So, just the distributive law again. So the x times the x squared. X times x squared is x cubed, so equals x cubed. Line it up if you can. X times the -7. So positive and negative makes a negative, yes. X times 7x is 7x squared. Remember, you got the 2 x's. X times x is x squared. All right, now the third one. X times -18. So positive negative makes negative. X times 18 is just 18x. Done. Done for the first bit. Now we'll go the second one. 3 times the x squared. It's positive, positive, so plus, and 3x squared. Second one, I'm going to speed up a little bit now. Positive, negative makes negative. So we'll have a negative. 3 times -7x. 7 3s are 21. And the x is there. And last one, we'll do 3 times -18. So positive and negative makes negative again. 3 times 18, 10 3s are 30, 8 3s are 24. So that will be 54. Okay, good with that? Is there anything we can simplify though? Let's have a look. So let's look for our x cubed terms. How many x cubed terms have we got? We've got 1 there and there's no others. So we're just going to write x cubed down there. What about the x squared terms? Well, we've got -7x squared. Now see how I've circled the negative here as well? You have to count the sign in front. -7 plus 3. -7 plus 3 is -4. So we've done our x squareds. Now what about our, well, there's an x term. Have we got any out? There's another one down there. So -18 minus 21, -39. There we go. And so we've done the squares, done the x's, and now we've just got the -54 on the end. So poor old -54 just tags along down the back. All right. That's as hard as expanding gets. It's all just the one law, just the distributive law. You're just distributing whatever's out the front by everything that's left over in the brackets. All right, time to get some practice. I'll see you next time around for factorizing. Good luck.